Okay, so we're gonna talk about sine, cosine, tangent, and the other trig functions of 30, 60, 90 angles today. So here we have a 30, 60, 90 triangle, and you can see the long leg is missing, right? But since the short leg is 6, this one is 6 root 3. And here I modified these. We have to find sine of 30, cosine of 30, tangent of 30. So since it's the 30-degree angle that we're dealing with, I highlight the 30-degree angle there, and I label these sides opposite, adjacent, and hypotenuse. So now, if I want sine of 30, that's the opposite over the hypotenuse, which is 12. That's 1/2. Cosine of 30 is the adjacent 6 root 3 over 12. And if I reduce these, I get root 3 over 2. Tangent of 30 is opposite over adjacent 1 over root 3. And for the other ones, the reciprocal ones, I just take the reciprocal of the ones that I already reduced. So 2 over 1, 2 over root 3 over 1. Okay, now take a look at this next one. I have a very different 30, 60, 90 triangle, but I'm still going to do the same thing, and let's see what results we're going to get. So again, these are going to be 30, 60, they're all going to be 30. So tangent of 30, cosine of 30, right? These are all of 30. Now, here's what we're going to do. So take a look at this. I have a short side of 10, long leg of 10 root 3. The hypotenuse is going to be 2 times the short 20. And now if I'm looking for sine, cosine, tangent, and so on of the 30-degree angle, here's my 30-degree angle. I label these as opposite, adjacent, hypotenuse. So sine of 30 is opposite over hypotenuse, and that reduces to 1/2. Cosine of 30, adjacent 10 root 3 over hypotenuse, which is 20. So that's 1, that's 2, root 3 over 2. Tangent of 30 is opposite 10 over adjacent 10 root 3, and that reduces to 1 over root 3. And then again, the reciprocals, I get 2, 2 over root 3 over 1. Okay, so what do we notice? Take a look here. In a very different triangle, sine, cosine, tangent of 30, and here sine, cosine, tangent of 30, what do you notice? Well, they're exactly the same, right? So the moral of the story is it doesn't matter what the triangle looks like. As long as you're looking for, let's say, the cosine of 30, you're always going to get the same value. The secant of the cotangent of 30, you're always going to get the same value. Okay, now let's do the 45, 45, 90. Again, here we're missing a leg, right? So if this is 7, this is also 7, 7 root 2. Now if I want sine of 45, I highlight one of the 45s, and I got an opposite and adjacent. So sine of 45 is going to be opposite over adjacent 1 over root 2. Cosine of 45, opposite over adjacent 1 over root 2. Tangent of 45, opposite over adjacent 1. Okay? So this is always what you're going to get for sine, cosine, tangent of 45 degrees. Now, let's go to the next page. Okay, so here's a little summary. But what we're going to do here is, without a calculator, I want to find each of these expressions, the exact values. So, first step, draw a special right triangle, label the angles, determine the relationship of the sides, and then determine the trig ratios. So, take a look here. I want tangent of 30. Well, that means I need a 30, 60, 90 triangle because the other one's not going to help me. So 30, 60. Okay. The vertical leg, which is opposite the 30, we always give that a 1. We can really make it any number, but the 1 is preferred. Then the long leg down here will be root 3, right? 1 times root 3. Then the hypotenuse will be 1 times 2, which is just 2. So this is how your 30, 60, 90 triangles are always going to look. Now, since we're looking for the 30-degree angle, this is the opposite, right? Tangent of 30 is opposite over adjacent 1 over root 3. And that's it. That's your answer. Okay? Now, word to the wise. Back in the day, you were asked to never leave a root in the denominator. So we always multiplied by itself on the top and the bottom. And we always ended up with, so this would end up as root 3 over 3. I'm just saying this so you're aware that 1 over root 3 and root 3 over 3 are the same. Because even though I'm not requiring for you to rationalize the denominator, problems in the book and so on might come up as rationalized. And you should just know the difference. Okay, so next, we need to find secant of 45. So for this, since it's a 45-degree angle, I need a 45, 45, 90 triangle. I label one leg 1. The other leg has to be the same. And the hypotenuse is 1 times root 2, so it's root 2. Now, secant of 45 is the hypotenuse over the adjacent, so that's just root 2. Okay, next. Next, it says, without using a calculator, find the measure of the angle that satisfies this equation. So basically, you will be given this, but the angle is hidden, and you have to use that information to determine that, oh, that angle is 30 degrees. Okay, so here's how we're going to do it. The problem is cosine of theta is root 3 over 2. Okay, which triangle gives you a root 3 over 2? Well, that's the 30, 60, 90. Okay, 1, root 3, 2. Okay, as a side note, you don't have to draw these triangles over and over. If you just draw one of each, in the margins of your page, you can always refer to it. That's totally fine. Okay, so let's try this. We're going to do trial and error. Let's try 60 degrees. Okay, what is the cosine of 60? Well, it's adjacent 1 over hypotenuse 2. Did that give me root 3 over 2? Nope. So that's not it. Let's try 30 degrees. What's the cosine of 30 degrees? Okay, adjacent to 30 over 2. Yep, that's the one. Since the 30-degree angle worked, I say my answer is 30 degrees. Okay, next. I want a secant to be 2. Which angle gives you a 2? Well, it's the 30, 60, 90 again, right? So it's the same. You know what? I'm just going to use the same triangle. So what's secant? Secant is hypotenuse over adjacent. So let's try 30 degrees. What's hypotenuse? 2 over adjacent of 30 is root 3. Okay, that's not it. Let's try 60 degrees. What's hypotenuse? 2 over adjacent to 60 is 1. That gives you a 2. That's the one. So the answer is 60 degrees. Okay. And that's that. All right. Thank you very much.